Once again, welcome everyone to the Performance and Capacity Spree. My name is Piara Bamra and I'm going to be chairing this session. We are very pleased to have Martin Packer from IBM. I'm sure you all know. He's going to be presenting on how you can gain architectural insights from your SMF data. We're going to have some time towards the end to ask Martin any questions, or you can also ask questions as we go along the presentation, if that's all right, Martin.
That's perfect. I don't expect me to notice if somebody asks a question unless you alert me, Piara, please.
Yep. So to ask the question, you can simply use the chat box, or if you prefer to speak, I can unmute you as well. That'll be towards the end of the presentation. As with all our sessions, we would appreciate if you could leave us some feedback towards the end as well. And I'm going to leave a feedback link in the chat box, so you can do that. It will literally take 60 seconds. And yeah, I think that's pretty much it. And without further ado, I'm going to hand it over to you, Martin, now to start the presentation.
Thank you, Piara. So hello, everybody. You are being experimented on. That's always true. Every customer engagement I ever do and every presentation I ever do. But actually, this slot traditionally, more or less, would have been when we did a small working group face-to-face meeting, generally hosted by Lloyds, actually, but not always, when I would debut a new presentation. So this is sort of in that vein, although it's actually really a heavily modified one from one some of you might have seen in the distant past. And it's actually one I'm giving it a share, and probably another version of this in the autumn at the November conference. This frankly could be a 2-session pair of presentations, but right now it isn't. It's quite a busy presentation. I'll tell you that before we actually get going. So, as I say, please do ask questions whenever you like, really. I won't notice, but Piara might leap in and interrupt me, and that would be fine. Okay, so slightly provocative title. In fact, some of my American and Canadian friends have said things like, why don't you turn it around and say, so you do think you are an architect? Well, okay, fine. If you do performance, you possibly aren't an architect. There's at least one person I know who is much more architecty than most of us, who's actually in the audience. If you do performance, maybe you aren't an architect. But the whole point of this presentation is, if you just think about your role as pure performance, you're missing some very useful tricks. And I want to sample with you in the next hour a bunch of architectural-like things that you could do with the data you have to hand, that have real architectural insight and value to others in that vein. You know, you might turn out to be the only kind of person in your shop who could, in a systematic way, understand what on earth is going on from an architectural perspective, and that could make you very valuable. And hopefully by the time you've heard this, you will agree. So I'm going to take examples at various levels. This is not a complete treatment of the topic. Like I say, that probably would be at least a double session, and maybe we'll do that depending on how we feel. As I say, this is not doing anything exotic in terms of data swag. You have this data already, or you really ought to have in almost all cases. There are a few exceptions, but not many. Okay, so I don't want to rehearse the Wikipedia definition of a systems architect. It says something slightly different from what I think you can bring to the party and still wave around the word architecture. I'm actually challenging my second line manager at Share to tell me of a better word than architect, because I want him to understand this perspective too. So you might say this is infrastructure, not architecture. Fine, let's not get too precious about definitions. But as I say, matching this strict definition of an systems architect is not necessary to be able to bring architectural insight. Okay, so we're going to talk about things really at 3 levels. The top layer, which is things like machines, sysplexes, LPARs. Well, that's actually several layers in its own right, isn't it? But let's take that as one section. Then below that, the middle layer, which is really workloads and middleware. And the bottom layer, which we'll do relatively briefly, I think, today, which is about application components. And then we'll wrap up with some thoughts about how well does this actually correspond to a reasonable definition of architecture. And, you know, why hopefully this should be a good use of your time. Okay, so I'm not going to take you through the list in detail of SMF records we're going to talk about today, but they are typically RMF, of course, usage data in the SMF89, a lot of address-based data, type 30 stuff, and then into the middleware specific instrumentation. Actually, funny enough, the last two columns we're going to probably talk relatively little about, because you can do very scalable, good work in the architectural space without actually necessarily going to the middleware specific instrumentation. Okay, so let's get started at the top layer. So I mentioned RMF. At the very highest level, you're likely to be looking at SMF 70 subtype 1, which has been mentioned in several presentations already in this conference. You can ask questions, simple questions like what machines exist, what models are they, whether hardware or software, what is their configuration in detail, and kind of interesting to me and an emergent theme over the last few years, how does hardware configuration vary by, let's say time of day, probably not time of day, more likely time in the month. How do the machines behave? And things like, if I want to upgrade one, how far can I go without doing things like physically adding hardware or actually taking some kind of outage? So very briefly, this is an example real machine showing its LPARs in all the processor pools. The pools are the 4 rows, and obviously the ZOS LPARs can be in GCP pools as well as in the GCP pool, as well as the zip pool. This is kind of a good getting started trying to discuss what it is like to operate the estate that I tend to do with most customers I work with. The purple here is actually one particular Sysplex, and the light blue or turquoise is another, and so on. Color code for Sysplex is because it makes the discussion relatively easy. Now, a couple of things you can't get out of SMF. You can't get the name of machine. So actually, I try and work out what people are calling their machines and use that as a name, and generally I get it fairly close to right. Likewise, we don't know in RMF how much memory is purchased or physically installed on the machine. You have to use vital product data or the modern equivalent for that one. So those are two limitations of the method. Now down here, bit of a tourist note. The reason why 2 gigabytes is in red is because ZOS 2.3 onwards will give you a nasty gram if you try IPLing with less than 8 gigabytes, right? So I always think it's useful to put orange for 8 gigabytes and red for anything less, just to remind me to say, well, what is this about this CPE1 LPAR that you're prepared to try and run it in only 2 gigabytes when you're getting warnings about potential instability for trying to do so? So that's a high level thing. Now, as performance people, we're used to looking at data in a particular way. So let's try this one on you. This you could consider a performance chart. It shows the general purpose engine pool for a machine across several days. All it really says from the performance point of view is the pool probably does peak more than 80%, but really it's not a terribly busy machine from general purpose engine pool point of view. So that's a performance statement or capacity statement, if you will. Now consider looking at it from a slightly different perspective. Same graph, little bit of annotation. Trivially, you can see when Saturday and Sunday are, even if you didn't know that the 9th was a Sunday and the 8th was a Saturday. Who cares? That's not the major point here. You can see over to the left that there is fairly consistently a morning batch window peak. It moves around a bit, but that's a thing. You can see the daytime bundle, if you like, of utilizations across the days is reasonably consistent. Yes, you can see some variation, but you get the rhythm of the machine. And there's a regularish late evening peak. So we're beginning to get behaviors which aren't necessarily performance behaviors. They're things about how it is to operate this, that we have these peaks. that things are obviously happening in those that might be of architectural interest. But that's really the beginning of this story. So that was about patterns, that last slide. If you go down with SMF72 subtype 3, this is actually summarized at the workload level, not the service class or the report class level. And yes, of course, you would typically do those things. So this here gives you some idea. We've got this amorphous blob of stuff called started task. We've got some batch, and we see how it's driving the peaks in one of the LPARs in the machine we just looked at, and obviously system supports. So you begin to get some idea, very high level at this point, of what the LPAR is for. You don't know what this started task is, right? You just know it's started task and looks a bit like it might be an interactive thing. It almost certainly is. And by the way, tiny smidgen of DDF distributed DB2 work here. Really nothing much to talk about. But before we actually do that drilling down, let's look at what this LPAR is. So let's look at sysplexes. So from the SMF data, and I'm going to skip to the bottom and come back up, we're talking SMF70 subtype 1 again, because that gives you the systems, the ZOS systems in each sysplex, but it doesn't give you the coupling facilities in the sysplex. However, 74 subtype 4 lists the coupling facilities in each sysplex, and you can relate that to the 70 subtype 1 LPAR information, which may be handy for you. So between the 70 subtype 1 and 74 subtype 4, you can pull out the sysplex information. I will say 74 subtype 4 has lots of other information in it, and this is not exhaustive in any sense at all. It gives you a lot of information about link types in detail and their distances, as we will see in a minute. And actually, you can supplement the link type stuff with some SMF73 channel path activity data. Right? So we can ask questions like, what sysplexes are slung across the machines? What systems are in those sysplexes? What coupling facilities are in the sysplexes? And something we won't dwell on here, but if this became a double length one, we might. What structures? Which coupling facilities are they allocated in? Are they failure isolated? Are they duplexed? And as I say, distance. So we can ask a very useful question, which we should ask, which is our design resilient? Now, armed with information here, you can actually go into battle and have that conversation with people about, I see this structure is not duplex, it's actually not failure isolated, it's a vital one like a lock one. Now let's talk resilience, right? So you can talk to resilience people with that sort of information from the data. And the whole point about this is you can do a lot of work from the data in this space. Okay, so here's an example. It's a real customer, names are changed. The distances are not changed. So we have two data centers, data center 1 and data center 2. We can tell from the 74 subtype 4, the distance between the two data centers is 20, well, it's not distance, it's latency. Signaling latency is 23 microseconds. What we actually know from that is the distance, signaling distance, is 2.3 kilometers. And we know these two data centers are 2.3 kilometers apart. And these are obviously going to be long distance links like CELR or ISC links. You can see that from the data as well. Meanwhile, in each data center, we have two machines, and we know they are very physically close together because the signaling latency is the minimum it can be for a physical link of 1 microsecond, which is pretty close to 100 meters. Not necessarily sat next to each other, though typically in these configurations they are. So we can see we've got two data centers 2.3 kilometers apart with two machines in each. These machines have actually, and this is a real example, very few systems in this sysplex, and each of them has a coupling facility in the same physical machine. So this is where I say things like, do we have failure isolation given we haven't got any external coupling facilities here? You can tell all that from the data. Another compact way, which I won't bore you with for any longer than necessary, is simply listing the sysplexes, which I've obfuscated the names and the boxes and the LPARs that are in them. And the blue here is just the coupling facilities. These are obviously monoplexes. These are 4 ZOS members and 2 coupling facilities, but they're internal coupling facilities slung across 2 boxes. 84, by the way, is Singapore plant, or was. Okay, so let's swing back to LPARs. So LPARs are getting much more complex, harder to keep track of. I do remember the dawn of time when there was MDF and MLPF from competitors and Prism came along, and it was considered exotic to have Prism doing anything at all, and maybe 2 or 3 LPARs in the machine wall a machine could have. Now it's incredibly common to see double figures in terms of LPARs on a machine. I would say while their configurations are interesting, particularly from the performance point of view, so are the names. And I would also say that configurations these days are less static. And with HyperDispatch, that dynamic nature makes things even more complex than before. So 70 subtype 1, as I previously mentioned, is very good at describing LPARs. Passing mention of Z16 is we have as I think I said yesterday, we have the topology information for the logical processors for each LPAR, including non-ZOS ones on Z16 and SMF 70 subtype 1. I also mentioned yesterday System Recovery Boost, which I don't think we're going to talk about more than briefly today. But overall, what an LPAR is for is an important architectural question, and we'll get to that. Before we do, looking at inactive LPARs can be quite instructive, particularly in recovery scenarios, particularly if the LPARs that are inactive on a machine have similar names to other machines' active LPARs. Right. Now, in the following, which is a real example, I don't even think I've changed the names here. I've got a notes field. Now, in reality, what happens is you do the thinking and you supply the notes. They're not in the data. But if you look at, take the first one, for example, LPAR called N1 prod XX. On another machine is an active LPAR called S1 prod XX, whose system ID is MVSX. So you would probably suppose once you start seeing this kind of pattern repeated, these are standbys, but inactive standbys for active LPARs. And that's part of the resilience story, which is, oh, right. So if you're going to recover MVSX's workload, you're going to have to activate an IPL N1 prod XX on the other machine. The other part of this story, by the way, is this counterpart memory says, well, MVSX had 20 gig of memory on it. So above what's allocated to the LPARs, we'd better have that kind of memory for N1 prod XX to use when it starts up. Likewise, the rest. So you could do some useful work here, which says, do we have enough memory? And remember, we don't know how much memory has been purchased just from our RMF SMF. Do we have enough memory even to recover to these standby inactive LPARs? So again, that's part of the resilience, and actually it is memory capacity planning aspect of things, but particularly resilience. So inactive LPARs in the data can be useful. Now, the way you get at them is in SMF 70 subtype 1, there is an LPAR data section with the details you can see below. No logical processor data sections for that LPAR. That's how you know an inactive LPAR, as opposed to an active but not IPL'd LPAR. Okay. IPL timing in its own right is an interesting topic, by the way. And just to do this very, very quickly, I tend to use master scheduler address space reader start time as a good signifier of an IPL, because I don't think you can restart master scheduler address space within the life of an IPL. But if you want to use SMF 70 to do it, this APAR, which is quite old now, will give you the IPL date and time in store, I think it's store clock format. Currently, I'm mapping this, but not actually actively using it. Now, you could say, I keep my type 70 data longer than I keep my type 30 data, so maybe you can get the pattern of IPLs further back. This one here basically is showing a rippling IPL across 3 machines and 2 LPARs on each, actually in the same sysplex. I haven't shown the sysplex, but they are. One question to think about is maybe it's time to update the mean time to recovery Redbook, because I think there's a lot of stuff in this presentation and others that could be added to it. one interesting thing, and this is back to performance briefly. If you're looking at a set of data from a customer, and I know some of you on this call do that, it's a good idea to know how long it was since the last IPL. Actually, how long since, for example, the DB2 subsystem came up, because anything you might say about memory usage, about CPU, about buffer pool effectiveness is going to be conditional on how mature those buffer pools or that subsystem actually are, because it could take days or even weeks to establish a working set of buffers. So knowing when things started, and we'll go into a bit more detail in a minute, it's a useful architectural thing to do. Okay, so let's get down a layer. So SMF89, quite surprisingly, yields DB2 subsystems and queue managers and much more besides. Now, it's actually cut at the system level, but what I've said is still true. We'll talk about how you do this with SMF30 in a minute, but you may not have SMF30s for every system. There really should be SMF89s for every system. So if a product uses IFA usage, that leads to an SMF89 subtype 1. And that would be products like ZOS, KIX, DB2, MQ, and IMS. If, however, they use IFA EDREG instead, and many products will use neither, that one leads to SMF89 subtype 2. So two different macros here. So for example, ZEDC compression entitlement would be done via IFA EDREG, and ZCX entitlement would be, and the COBOL compiler would be. By the way, just because something appears in the 89 subtype 2 doesn't mean it's actually used, and doesn't mean we can necessarily detect which address spaces it's being used in. There's a bit of a difference between 89 and 30 in that regard. So one key nice thing is SMF89 subtype, this should say 1, shouldn't it, can yield DB2 subsystems and MQQ managers, because those names are encoded in the product qualifier field of SMF89 subtype 1. And this is just a real example with, here's the systems, this is DB2 at the top. Here are the subsystem names. Those do appear in 89 subtype 1 in the product qualifier field, exactly as you see them. And versions, which, yes, I could tidy this up, of course I could, but this is exactly how it comes. And product number. Actually, this is the product ID field. And in Danilo's presentation on ZOS Connect, this is what I was talking about when I said you can pick up ZOS Connect address spaces in the 30 because they have a product ID of whatever it was, 5655 CE3 or 5. MQ, likewise, you can pick up the queue managers and their level from the 89 subtype 1. So you can start to be going, well, we can see some DB2 and MQ in this LPAR just from the 89s before we go down to the 30s. And as I say, you may not have the 30s for some of your smaller LPARs or even some of your bigger ones. Okay, now back to RMF a little bit. You can do a lot of useful work understanding workloads, as we saw earlier, service classes in more detail and report classes in more detail. Their rhythm is interesting, particularly CPU and zip. And yes, I know those might be performance numbers, but you look at them, as I showed you at the higher level, as a rhythm of things. So that has some architectural bearing. And you can see things like transaction rates in many cases, all from SMF72 subtype 3. One thing I would say is ensure the description fields for workloads classes and report classes are useful and accurate and well spelt, because they will appear in SMF72 subtype 3. And that's exactly what I feed back to customers with their data, because I want to understand what this report class is really for. The names can be illuminating. Now, if you're going to use the description field or the names, please don't encode your goals in the name or the description, because the wind will be stuck with an inaccurate name or an obsolete description. I would say use report classes comprehensively for classification taxonomy as much as for doing CPU breakdown. And I know people use report classes to avoid using type 30 for CPU breakdown. That's fine. But I would say, think about them as a way of understanding the workloads from a taxonomy point of view. Okay. I'm going to leap ahead here to the bottom and say, one of the things I like to do, and you'll see an example in a minute, is actually understand the peak to average ratio of CPU for SMF30, from SMF30 for things like HSM and catalog, because I can have conversations with customers that say, I see HSM spikes at 9 a.m. every morning. Is that when you do your daily space management? So that's beginning to understand, when things happen, which is, I think, part of infrastructural architecture. Now, having mentioned those two address spaces, here's a nice one. Dump serve is something I also do exactly the same thing too. Now, you have to bear in mind these blobs here are powers of 2. So this is exponential or logarithmic, if you want, depending on how you want to view it. So something happened on this system that caused a massive amount of EXCPs in dump serve. In other words, there was a burst of dumping activity that was of some severity or some significance. What happened? And I think as a performance person, if you're doing this sort of thing, you can say, well, dump serve got very active at this point. Was there something nasty going on at that point? That's just a nice one I like to use quite a bit. Okay, now, having mentioned SMF89, I will say SMF30 usage data section is actually more useful where you have it. So, for example, every KICS region, every DB2 subsystem, every MQ manager writes at least one usage data section in its type 30 in an interval. Actually, step end, job end as well. They always contain the software level. By the way, I'm seeing a lot of VUE. So actually, again, product ID is useful for decoding VUE. Minor point here, I can't tell the difference between KICS 5.1 VUE and 5.2 VUE, to use two old releases, because it's not encoded. At least I know it's not version 4, and it's certainly not version 6 either. Often you see the subsystem name, as I've alluded to. So in the 30, the DB2 subsystem is the product qualifier. For MQ, it's an encoding. So it's not hard to take the BATC off MQ01 from the address space and go, it's got a batch connection into a MQQ manager called MQ01, right? And that's particularly useful for batch. So if you want to know whether a batch job uses DB2 or MQ, you can do it just from the usage data section from the 30. Use step end or job end, which Mary mentioned in her presentation kicking off this morning. And you know this without using DB2 or MQ instrumentation. And furthermore, you get the subsystem name. So you can say this batch job actually sits there all day long, waiting for stuff to come off a queue or put on the queue from this queue manager. And I've seen that in customers where batch jobs really aren't batch jobs. They're very long running address spaces driven by MQ queues, or conversely, actually they are DB2 jobs. Now, if you see a batch job step with LKJEF1B as the program name, you don't necessarily know whether that's actually running a bunch of TSO commands, or it's Rex, or if it's DB2 and using DB2 TSO connection type, unless you look at the usage data section, and that will tell you for certain that it's DB2 or if it's not. To state the fairly obvious, even without the usage data section information, you can often detect components. So for example, ZCX or IRLM or KICS data table server from the program name and or the Unix program name. Generally, the 8-character program name is the more useful, but both of them are available. Okay. Right. So this is just a very quickly encoded in the usage data section is the product version. So you can get within some limits information on the level. So you could run, if you weren't doing KICS VUE, you could say, tell me all the KICS releases that were 5.1 as opposed to those that not releases, all the KICS regions that are at 5.1 as opposed to 5.6. And quite often you see customers halfway across the river from one release to another. ZOS is a very good example. All 4 systems here are 2.3, but I'm seeing customers who are a mixture of 2.3 and 2.5, and they say, well, at that point in time, we were halfway across the river to 2.5. That's an interesting conversation where I can say, okay, well, when do you plan to complete that? Oh, we've already done it. And then I can ask the follow-up question, which is when you're going to go to the next release. Nice discussion to be had with customers about that, if you're sufficiently nosy. This is breaking down, firstly on the left, using SMF72 subtype 3. And you can see in that WLM-STC service class I mentioned earlier that wasn't particularly, workload that wasn't particularly useful as a name, most of the work is in STC kick. And then obviously you can drill down to STC kick service class CPU at the address space level. This is the top 15. It's quite nice to know the top 15 address spaces out of 25 are 95.5% of the CPU. Nowadays, a modern version of this, by the way, I have the service class CPU as a line, and you can see how, whether there are times a day when this 95.5% is more true than others. One footnote here is you can begin to see evidence of cloned regions. So this orangey one is probably a clone of this turquoise one, for example, and maybe the green is another clone. Maybe this is better done with a line graph. Actually, I'm not entirely sure that it is 100% better. You can graph the same thing twice with a line graph or a stack bar, and maybe you get insight by doing it both ways. Okay.
Sorry, Martin, can I just, we've just had a question in the chat box, if you don't mind.
Certainly.
So someone's asked, would the SMF30 subtype 6 interval be useful for long-running tasks like DB2 and KICS?
I'm not really very familiar with subtype 6, but I would say interval record, hopefully this is a useful answer. Interval records, subtypes 2 and 3 are very good for long-running tasks like DB2 and KICS. In fact, the graph I was just showing is based off subtype 2 and 3. Now, if whoever asked the question wants to come off mute and explain why subtype 6 as opposed to 2, 3 might be useful, I'd be very happy to hear it.
Okay, I've
Can
just
you hear
asked
me?
John. Oh, I think, yeah.
Somebody, yep. Hello.
Hello, Martin. I just meant the SMF interval records. I
Okay,
I
fine.
believe it was
Fine.
the subtype 6.
Well, subtype 2 and 3 is what I tend to work with, actually, and the previous graph
Okay.
is indeed off subtype 2, 3, 2
Okay.
and 2 and
Okay.
3. All right, thank you.
My only comment was that if you're looking for job and step records, we're not going to get those in long-running tasks until the step ends or the job ends, which span many hours. And the interval records, the SMF interval records, can get cut every 30 minutes, say, and you can get valuable statistics from that interval record.
Yes, that's absolutely right. And by the way, you could say the same of a counting trace.
Right.
it's cut at end, which is particularly unhelpful for some things, particularly if you only have a very narrow window to look at. Yeah, good.
Okay.
Yeah,
Thank
good
you.
point. All right, thank you. Right. So, whoops, having mentioned, I'm going forward too fast. I'm just trying to get rid of a window here. Okay, right. So you can do some quite interesting stuff for DB2, understanding a subsystem without actually using DB2 instrumentation. And that's useful because, for a start, a counting trace isn't always available. And as I've just said, you may have a very narrow window of it that somebody's prepared to turn it on for. And I have a customer who turns on KICS in some subsystems and DDF in other subsystems, and I can't talk to them about balance if I'm relying on a counting trace that isn't always there, right? And as much to the point, this is a scalable method I'm about to show you, but it comes with a small health warning. So first of all, from the 30s, which subsystems exist, and actually from the 74 subtype 2, in which data sharing groups are they? What attaches to them is a very good question to ask. What is the point of this subsystem? When is this subsystem maintained? Because you might be able to use spikes analysis to tell you when utilities run. If you're looking for program DSN util B or competitors, alternative ones, you can find those in the 30s, right? Whether it's step end or or whether it's interval. So let's get into that a little bit. So here's something I often produce. This is a real one. I may well have changed the system names. I haven't changed the versions. I haven't changed the subsystem names, and they're in the data sharing group. And I'll tell you how I did that in a minute. And here's one on another system. Actually, it's on the same system as one of these members, but it's in a completely, well, it's not in the data sharing group at all. The none means no data sharing group. You can do this very readily. So the first thing is you can accurately get data sharing group names inferred from structure level SMF74 subtype 4. So for example, GBP0 will always be there with DSN whatever in front of it, right? And you can look at the duplexing scheme, and that can drive some useful white space coupling facility memory discussions. And the request rates to those structures might suggest relative importance for the data sharing group and maybe for the buffer pool. The way I do membership of a data sharing group is actually with SMF74 subtype 2. And Peter Enrico yesterday mentioned the DXR and IXCLO groups. The RLM traffic in the DXR group is the one that I use for picking up the data sharing group. So if you have an RLM and it's in the DXR, DB0P group, I pick up DB0P as the group name, and you can see the RLMs. Now, what you have to hope for here is that the RLM address spaces and the DB2 subsystem engine address spaces follow a naming convention. Otherwise, it's very difficult to pick this up from SMF without going into DB2 statistics trace. So that's really, if I go back, that's really what I've done here is I've used the XCF group DXR DB0P and discovered that the RLMs for these subsystems have the same first four characters as DBM1, master, and dist. Fairly simple trick. And you might say, well, I don't have many DB2s, but you'd be surprised how many data sharing groups a typical customer have and how many members they have in them. And what I discovered about 3 weeks ago in the customer is, if you have a data sharing group of 13 members and one of them is down, you won't, by this method, spot that 13th down member. That's a minor limitation, I think I would say. What's also interesting is sometimes you see a subsystem in the data sharing group with the name DB2P or similar, and the rest just don't follow, DB3P, DB4P, and so on. And that probably is a bit of an origin story, that originally DB2P was the only subsystem, and then they went data sharing and added the subsystems, but didn't, quite sensibly, rename the original one. That's kind of interesting to see that happen. Now, I've abjured DB2 statistics trace so far, but no longer, because what I'm going to say very briefly here is you can get useful architectural footprints. So this is actually a real customer, their DB01 data sharing group, where I've stacked up all the local pool sizes for each member, and this is just a suffix. Each one of these stacks is a different subsystem. Now, there are 3 massive buffer pools on 4 of the members, which are either not present or tiny on the other 5 members. That tells me something about these 4, 0, 2, 5, and 7 versus W, X, Y, Z, and 1. They are configured differently. Now, that might be an interesting line of inquiry as to why that is. Having taken away those 3 massive buffer pools, here's the same thing. Now you can see these 5 subsystems have very similar buffer pool configurations, and these 4 are again different. And now you see 0, 1, 2, 5, 7 and W, X, Y, Z now look distinctly different from each other. You could play the same game with buffer pool thresholds, which might be useful. And one of the questions I think you'd want to ask is, if you've got different buffer pool configurations for the members, does that in some sense inhibit resilience? Or do you expect in a recovery scenario, the buffer pools to be enlarged of a small surviving DB2? Interesting resilience question we've asked a couple of customers. Okay, DB2 subsystem roles. You can get that from SMF30 with a bit of a health warning, which I'll come on to. So this is a real customer. most of these are actually one data sharing group. In fact, DB3P all the way up to DB8P are one data sharing group. And then you see from the naming convention, this is another data sharing group of 2, another data sharing group of 2. There's a queue here and another queue and another queue and another queue. So that's one of 4 and so on, right? And the trick with the XCF, the XR would have told me the topology, right? But I think this is a more interesting example because of what I can see in terms of the connections CPU. I'm going to have to explain the term SMF30 connections GCP CPU to you, and I'll do that in a minute. But if you look at this, you can see pairs emerging. You can see these two are a pair because they both have about the same amount of kicks, about the same amount of DDF, and about the same amount of other, and a bit of batch in one of them. But basically, they look very similar to each other, DB3P and DB4P. Likewise, DB1P, DB2P don't look so different, apart from there's a bit of batch in here. And likewise, DB6P and DB5P don't look so different, apart from the amount of batch. So the structure of pairs of subsystems emerged in this example quite nicely. This is, I think, quite a good broad brush approach, but let me explain what top DB2 connection CPU is. All I've done is I've taken the usage data sections for anything that connects to the DB2 subsystem, because the product qualifier says it connects to it, and I've summed up the thing connecting's CPU. So for example, the kicks region, I've summed up the kicks region's entire CPU. And yes, I know that not all of that will actually be in DB2, but it's a good broad brush approach to say, yes, this subsystem has got a lot of kicks work connecting to it. I think I'm probably going to skip the detail on this, right? And I've actually added in the DBM1 and master and dist address spaces into this equation. If they're 0, I just delete that column in the spreadsheet. As I say, pairs of subsystems emerge with similar total connections, CPU and proportions, and the names are quite interesting here, as I think I've shown you. Okay, you can do the same thing for MQ, and I very often do. One pro tip here is it's useful to show both the absolute, which is this view, and the relative view, so make them all stack up to 100% side by side. And then you get some kind of insight about pairs of subsystems, or maybe more than pairs, and what each one or each set of subsystems is for. Works for DB2, works for MQ. Also from the 30s, you can get DDF transaction rates because they are independent enclave transaction rates from the dist address space. So here, real example, different ones from the ones you've seen before. By and large, we've got balance between the 4 subsystems. So workload distribution is working nicely. Bit of a wobble maybe round about here, but this is very nice. This is very scalable. If you collect 30s, you can see, like in this case, you can do many days at a time to establish the pattern. I thought this was a nice one because it showed balance rather than what I often see. And in fact, actually, I was working with customer data earlier this week, where there was definite imbalance between 3 DB2s that handle the DDF workload in a Sysplex for a customer. Okay, while we're talking about DDF, you can get information from 30, as I've just shown you, the enclave transaction rate stuff and CPU and response times. You can also get it at the service class, report class level, and you get more granularity in buckets, really, if you want them for transaction response time, which I use for WLM tuning. And if everything's in bucket 1, which it often is, you probably need to tighten the goal, but that's really a performance observation rather than an architecture one. So you don't actually have to go to DB2 accounting trace to do some useful DDF work, but there's so much more if you do. Which is the subject of a completely different presentation I've given several times at GSE and other places. One caution on high performance DBATs, which a lot of DB2 shops are doing now. Recent DB2 maintenance will actually completely invalidate almost all of the above, apart from the headline CPU number. But you can't do how CPU intensive is a transaction from 72 subtype 3 or sub 30 with the traditional fields. You have to use the new 72 subtype 3 fields, which are part of the maintenance, I won't say package or bundle, maintenance you should apply if you've got high performance DBATs and somebody's done the DB2 maintenance to change the behavior. I think Scott might be talking about this sometime. Okay. We're running a little tight on time for questions, really, but let me plow on. You can do a lot of useful work for kicks. You can usually guess what kind of kicks region it is. You can see cloning, you can see restarts. I've got a nice example here. You might see useful EXCP counts for AORs or even some of the Unixy stuff. XCF traffic might tell you something, though be careful because two kicks regions in the same system are probably not going to be using XCF to do MRO traffic. You can see virtual storage allocations, and similar regions often have very similar virtual storage allocations. I mentioned the version thing in SMF30 usage data section already. If you start seeing zip usage in the kicks region, that could tell you something modern is happening, like Java or maybe System XML. Actually, if they're using Liberty, which is a typical way now of doing Java in the kicks region, there is a license piece of evidence, which is, guess what? The usage data section for that kicks region will include a Liberty one. Now, it says something useless in version terms like 0.0. So really, you have to take your cue a little bit from the actual kicks DFH SIP usage data sections level. Not 100% scientific, might be a useful way of doing it. And CTG is almost pure Java. It's not really kicks, but you often see it associated with kicks, and you can pretty easily pick it up. Actually, as I showed you yesterday in the zip presentation, with the program name being CTG batch. I'm going to whiz through this very quickly because I want to get to the text behind it. This is just a system and another system and their DB2 subsystems, which of course you can tell if they're in the same data sharing group, which these are. And then the kicks regions that attach, because every kicks region that attaches to a DB2, as I says, has encoded which DB2 subsystem it attaches to in the usage data sections. Now I've color coded these. Actually, I think it's report classes in this case. I spend a lot of time when I've got the time budget, analyzing kicks regions to try and understand which applications they support. And here you can see by the various metrics, some degree of cloning of regions across these two systems and also within each system. So that you can get some interesting architectural information that way. Likewise, MQ. Now, this is what I wanted to get to. As I say, I've colored based on report class. You could do it based on other things like service class, maybe like CPU, or whether the XCP counts are significant or not. Some of those regions actually had extremely high XCP rates in that example, which turned out to be for VSAM RLS and corroborated with SMF42 subtype 6 for the SMS VSAM address space. There is, of course, some variation between cloned regions evident there. There are some average CPU consumption figures in that data, those two examples, that might worry you, but probably because it's connecting to DB2, maybe less so MQ, the QRTCB is only a small subset of that CPU. But, you know, when should I add more clones or even clone at all is a good architectural and resilience question to be asking. Maybe you can guess something from the names, like the ones with T in them are TORs versus their AORs, and those probably would have low CPU and low IO rates. I could have added in the XCF stuff for the DFH IR 000, which is the default XCF group for kicks. Now, the other thing is these slides are static pictures, those last two. Time of day could well prove very interesting in this. Now, there are some kicks-related address spaces that don't connect to either DB2 or MQ. For example, named counter servers, some kicks regions, temporary storage servers, data table servers, CPSM CMASs. Now, in this example, there aren't any of the name counters or any standalone kicks regions or any CTG address spaces. Actually, the more modern version of this code, which this customer didn't have, but a recent one did. ZOS Connect, I would be putting that on this on this diagram programmatically. Now, I will say the KICS Sysplex address spaces don't tend to have XCF groups to really help you work out what ensemble they're in, but they do have coupling facility structures. So, for example, the data table server, you will see the appropriate coupling facility structure to make that even work. Likewise, temporary storage service, but here we got two. Now, which coupling facility structure is associated with each of these? That may be difficult to guess. So that's why I say may not be immediately associable. Okay, now here's an interesting situation. This is from yet another customer where what we have is daily KICS region restarts with 30 to 50 minute downtimes between going down and coming back up again. You'll note, by the way, that the stop time is probably on a timer pop. It's a little bit freaky if it isn't. But the up times aren't necessarily on the timer pop. Now, the reason why I've been interested in this is, so dear customer, you're stopping KICS regions for 30 to 50 minutes every day. Why are you doing that? Do you really want to be doing that? Are you doing that to be able to run some batch in between, in which case do you want the batch to go faster to minimize that window or re-architect to avoid that problem? Sometimes you actually get a very short bounce, and that's often something like picking up new versions of files that the batch have created. I've seen that a few times. So actually, uptime, downtime, the gap in between down and coming back up again is an interesting thing to actually consider from an architectural point of view. IMS, I think I will just say, you can do some work with IMS. The usage data section here doesn't tie together the system regions and the the system regions like control region and the dependent regions. You may have a naming convention, you may not. WM service class and report class might be some use in this. IMS less beautifully instrumented, I have to say, than MQ, DB2, and in fact KICS. ZCX, the main thing to say here is you can detect them with the program name of GLZBAIN in the 8-character JCL program name. And you can probably see a lot of useful stuff about it. We don't really have time in this presentation to talk about IO subsystem, but there's lots of configuration information in RMF SMF. You can't really see the distance, but you might be able to infer it from the disconnect a little bit. One very interesting question that's worth asking is, why is this channel rated at 16, but only going at 4? There may well be a good reason. There may be a very silly reason. We may be in transition because, let's say, the disks or the switches aren't up to speed, if you pardon the pun, yet. SMF73 Gen is a very nice field that gives really the answer to that story for every channel. And I'm very grateful to Patty Drever for keeping on feeding me the SMF Gen numbers as new situations come along. Okay, so very briefly at the bottom layer, fairly obviously middleware traces such as DB2 and MQ accounting trace can help you dig further into what's going on, what the role of a DB2 subsystem is, what the role of an MQ queue manager is, what connects. So for example, for DDF, you can get everything, including IP address, program name, version of the middle tier, that sort of thing. An awful lot of useful information for classifying DDF, as I previously presented on. I will say accounting trace where the DB2MQ is going to be voluminous, if not expensive. KICS monitor trace is going to be even more voluminous and even more expensive, incredibly detailed. Generally, you can fall back to DB2 or MQ accounting. But obviously, many KICS transactions aren't actually going anywhere near DB2 or MQ. And as Danilo mentioned, SMF 123 is a detailed record for ZOS Connect. So middleware traces can help you dig even further into the architecture of things. Similarly, dataset names can be useful. I particularly like DB2. So if you decode a dataset name, whether in the generally in 42 subtype 6, the database name of the object is the third qualifier. The table space or index space name is the fourth qualifier. And the dataset number in the last qualifier has multiple uses. For example, if I0001 has got all the IO in 42 subtype 6, and there's a bunch of other ones that have next to no IO in the low-level qualifier, maybe that's a hot partition. Less exotically, you can do partition counting. So, is it significant if I keep seeing table spaces with 54 partitions? That's probably one for every day. No, one for every week of the year. What if I see a plethora of 100-piece objects? And quite often we actually see 100 or 10 or 20 or 30. That might say the standard here, something like the standard here is when we partition things to partition them 100 ways. You might have an interesting discussion with your DB2 colleagues about why you see 100 pieces of a particular object from the 42 subtype 6. Another thought here, and I've alluded to this already, is pay attention to events, things like I already mentioned, restarts and IPLs, spikes such as DFHSM, space management, SRB spikes, when waypoint jobs finish in your batch, when LPARs and machines change configuration, and similarly, not just in discrete events, but rhythms. So, for example, the fact that the WLM policy is switched from a day policy to a night policy at 7 p.m. and back again at 7 a.m. So events are something I'm quite keen on understanding in the life of a set of data that I get, because that may explain some performance things, but equally it can be architectural insight. So just to finish off, because I'm basically out of time, but I'm happy to hang around a little bit for questions if people want to. If you do all the things I've said, you probably still aren't an architect, but the role you can play is very valuable because you will have a much better understanding of what's really going on than if you don't. You may be the only person in the shop who really has that level of understanding. Those insights you can bring could be very valuable to the real systems architects. It does give you an up-to-date view of the estate. Actually, a lot of the things I've said architecture have some bearing on capacity and performance, so they can help in your day job role of performance and capacity. You could, and I've given a few examples of this, be able to contribute really quite handily to resilience discussions. So maybe your job could become CR, A, and P. I'll leave you to your imagination as to why I said that. For me personally, dabbling in architecture keeps me interested. I won't say performance and capacity are boring. I think I don't think they are. It just provides another angle, and it gives me a way to find patterns among customers. It enables me to get closer to what a customer is actually trying to do and the shop they're trying to run and how it works. And I'm finding over the last few years, it's enabled me to collaborate with the High Availability Center of Competence people very nicely, and with the DB2 SWAT team and Kix Lab and a few other people very nicely, if I take an interest in the architectural perspectives. I'll come back to this one in a second. So I'm seeing increasingly complex estates, ever harder to keep track of. You need scalable ways of doing it. And most of the things I've said in this presentation have been really pretty scalable. And actually those techniques are still valuable even for smaller estates. So a question which I don't think necessarily we should answer right now is, would a cookbook that details these techniques actually be a valuable contribution? My personal view, I'll tell you, is I think it would. It's quite a big undertaking, which is why, I won't just do it just because I think it's interesting. That's why I've done the presentation, because that's a more consumable thing to write and to keep updated. So that's all I have that will fit into this time frame. There may be a little time for questions, but only a little. So I'm very happy to take them or take them offline.
Thanks very much, Martin. No questions in the chat box at the moment. Yeah, I think if anyone does have any questions, feel free to ask away now in the chat box. Otherwise, I think you can email Martin as well. And if you've got an email address slide, Martin, if you can display that.
Actually, I don't. It's martin_packer@uk.ibm.com.
Okay.
I'm also findable on Twitter and believe it or not, just to be down with the middle-aged people, I'm on Mastodon as well now. And LinkedIn and all sorts of other places. So yeah, I mean, look, I learned some stuff from Danilo's presentation and from Mary's presentation and from some of the others yesterday that kind of fits in this whole category of architectural insights. So I'm learning. I think we probably all are. So if you have insight, then I'd very much like to hear it. Otherwise, all of us are getting hungry and thirsty, I would think. Well, many of us are.
Yeah, well, I won't keep anyone too long. If there's no other questions, I think we can end it there. Thank you so much, Martin, for the presentation. Really appreciate that.
And some of you I know I will see at Share, where I will be doing this again with a few tweaks.
Yes.
And some more in the fall. Okay, thank you, everybody.
Perfect. Thank you, everybody.
Yes,
We'll
sir.
be back here in the next hour at 2 o'clock for the next session.